Hello and welcome to the Pinot meetup. I'm Matt Landers. I'm probably a new face. I am the head of developer relations at StarTree. This is my first time hosting, so I'm excited to be part of the team. Today we have a good topic, and that is data security in Apache Pinot. I'm excited to hear from Alex Pucher. He is at StarTree as a founding engineer. And just a little background on Alex. He's been doing distributed systems for over 10 years, and he contributed to major analytics platforms and delivered real-time insights at global scale, including with Apache Pinot, Third Eye, and LinkedIn's A/B testing platform, T-Rex. In this talk, he will review the number of essential security features that come out of the box with Apache Pinot. So without further ado, let's introduce Alex to the stream. Hi, Alex.
Hello. How are you guys doing? Good morning if you're on the West Coast. Otherwise, you are probably just having lunch. So I'll be chatting with you about data security. Yes. One thing, thanks for the intro, Matt. And shall we just jump over to the slides?
Let's do it. All right.
Okay, wonderful. Okay, hi, everyone. Yeah, so again, my name is Alex, or Alexander Pucher. Before we dive into this, let me give you some background. One is, of course, me having to switch to the right screen. There we go. So yes, I'm a committer in Apache Pinot, right? I've been with this crowd for just over 4 years now. I think I have a good insight. Pinot has been around for quite a while though. StarTree is kind of like now like the enterprise culmination of this whole thing. Originally came out of LinkedIn and Uber, and now has seen quite a bit of adoption in different places. Now, before I dive in the technical details of data security, let me give you more, context around Pinot. We'll just spend like 2 minutes on that or so. So, if you take a step back, right, and you look at, for example, LinkedIn's data infrastructure, then on the high level, it has kind of these two layers or two sides to it. The one is a write-optimized layer. On the left side, let's say Kafka, for example, does a really good job at this, right? Just collect events, collect metric information, just make sure that all the data arrives, that it stays in order approximately, and everything just comes through, even when there's high load on the system. And then on the other side, you would say you have a read-optimized layer. And this is really what Pinot is good at. Essentially taking all these individual events, aggregate them, analyze them, both pretty much the current events as well as some historical information, and then generate insights from it. And pretty much any kind of user that later leverages the information that comes out of Kafka will usually go through the detour of Pinot, which is also the data lake at LinkedIn. Also, maybe a little bit of business background. Of course, the company behind Kafka is Confluent. They also recently IPO'd. Behind StarTree, right? StarTree is the company behind Pinot. Started a little bit later, right? So a good 2 years now, and it's kind of ramping up. I will not bore you too much with the details. Yeah, I still have the slide in there. So if you need some enterprise support, if you need some compliance things, okay. So now there's an enterprise vendor behind it. But let me be clear that everything in this talk, or at least like 98% of it, can be done just with open source. So open source Pinot is actually really powerful, and actually also has quite a bit of a history when it comes to compliance and data security. And so if we kind of take the step back again and say, okay, well, we have Pinot and we have data coming in and insights coming out, there's usually a couple of, buzzwords or terms that come up. Of course, the high level, it's about data protection, compliance, just security in general. We'll mostly focus here, of course, on the technical aspects of this. And then in this talk, I figured I'll try to break down the concepts that are built into Pinot into, let's say, 3 major groups. I will talk about more the authentication and authorization part, then a piece about encryption of data, both in transit and at rest, and then more, let's say, summary chapter about some data management, retention, deletion, replication aspects, right? So I guess mostly an availability and compliance feature. Now, I think if you were to even drop off at this point. If there's one message I wanted to share and that I want you to take away, is that Pinot already has quite a track record when it comes to compliance and data security. I think one of the first big efforts in this avenue was that Pinot was a big piece of the technological answer to GDPR at LinkedIn. This was a huge effort, and of course, there's like many pieces that have to play into this. Right, it's not just the technology; it's also process. But Pinot is really the data lake, right? So it's at the core of this, and it has to fulfill different requirements, such as the encryption and the safekeeping of data, as well as allow things such as scheduled deletion and other things. And even though this effort is more or less complete now, right? There's always things that continue, but in general, GDPR is addressed. Now we've seen, especially over the past probably 1.5 years, quite a bit of an uptake of Pinot in fintechs. And of course, when you talk about the fintech space, then there's quite a few compliance and security needs that come from there as well. And you'll see this kind of driver of data security requirements really pop up a couple of times over the duration of this talk. Okay, so I would say from a high level, yes, we already have a history, but let's give you some actual concrete examples of how are different things maybe designed, then how does the implementation look like? But I also want to dive a little bit deeper and say, hey, maybe here's some actual concrete examples, right? So that you can see, hey, how would you configure, for example, authentication, or how would you configure TLS and SSL encryption in the cluster? So let's just start with this first part, right? And say, hey, if I give you a high-level architecture overview of what Pinot looks like, then this would be one deployment. This is actually a classic thing where you would say, okay, you actually have a cluster, right? You have components that are replicated, so you're already high availability enabled. And then you have on the left side events coming into these real-time servers, and on the right side you have your offline group of servers connected to some kind of deep store. Right? I put HDFS there, but of course it could be anything. It could be GCS, S3, or any other deep store that is available. Okay, well, obviously the first thing that you can imagine coming in is just a set of queries. Right? So obviously these queries are user generated, so there will be something that we'll have to do in terms of keeping our data safe. But on the other hand, also the data that flows back needs to be protected. But it's, of course, not just this. There's also some, let's say, other ways to ingress into the system. One is, for example, with metadata or just high-level management. Right? Typically, this is the so-called controller component that manages cluster state and other things and tracks metadata just of tables and schemas and these kind of things. So this is pretty much a second way how you can access data or you can access Pinot. And definitely something we'll need to keep safe. And finally, this is also more like an offline aspect of the system. There's the so-called Minion server. The Minion server is mostly responsible for executing offline jobs, pretty much doing scheduled maintenance. And in a way, these Minion servers process job specs, some of which are generated by the system automatically. Like, for example, taking some of the real-time data that was generated and just pretty much packaging and sealing these data segments, as we call them, and moving them to the deep store on the offline server group. Others of these job specs can be actually submitted by users too. Right? For example, if there's a batch ingestion job where new data is available, say somewhere on S3, and you want to pull it in. And these job specs, therefore, also contain some user-generated content. And there's some safekeeping we need to do, make sure that both the inputs as well as the outputs are protected. And now, let me break this down, right? I suggested I'll talk about authentication and authorization, the encryption piece, and then maybe more a data management, data retention piece. Okay, authentication, right? So if I redraw the same thing that I just showed you into maybe a little bit of an environmental context. Then we said, okay, we have job specs that hit Minion. We have queries that will hit the broker, and we have these metadata API requests that hit the controller. If I were to look at this in a naive way, I would say, okay, well, clearly we have these first three components. They're exposed, right? They'll take some kind of user credentials or service tokens. And then there is this, say, protected realm of the cluster where the servers sit and the data segments are being managed. And then we have a data plane, right, where we use NetApp, pretty much just a binary protocol to speed up the process. And then there's a control plane where we work on REST. This was actually how authentication was really structured in Pinot for quite a long time. But what we found is that oftentimes when Pinot is deployed, people don't just have a dedicated network for it or a dedicated VPC, but instead there's this shared environment, right? So you kind of need to really protect everything and make sure that everything is authenticated. So what actually ends up happening in the implementation is that we really use tokens for everything, meaning that every piece of the system has to authenticate itself, and sometimes even the request that is being sent fully to the other entity. Right? So we essentially assume that everything is exposed to some degree, and we don't really have a protected realm. And that's interesting because it allows you to pretty much deploy Pinot and don't really care so much about whether you have a sealed VPC or a sealed environment for it. Rather, essentially, you just set it up and make sure that these components authenticate to each other. These tokens, of course, they can have different shapes and forms. Right? You can think of configuring literally just something like basic auth, just username and password pairs, right, that are base64 encoded. Or you can go full out bearer tokens, or you have something in between where you have these classic service tokens, as you know them, with like access keys and secret keys. Multiple ways to configure it. And also, just to be clear, so in open source, right? Maybe to look at some of the features in detail, you could think of authentication not just as clients to Pinot, what's on the right side and what I talked about is here, but also Pinot talking to other data sources, which becomes relevant, especially when you take advantage of some of these batch jobs or job specs that can be run, or a real-time ingestion, right? And so if you talk to, for example, a Kafka cluster, right? Pinot has a Kafka consumer, and this connection might actually require, say, TLS encryption, depending on which kind of environment we're in. At least you'll have some kind of basic credentials usually, right, to authenticate to the cluster if it's not wide open by itself. Of course, the same applies to other things, deep stores, right, like HDFS. There's even Kerberos support there in there as well. Same applies, of course, to S3, GCS, ADLS, other things where you simply provide access keys and secret keys. And usually, which kind of authentication of Pinot to data sources is available depends on the plugin. There's a certain standard that we, of course, expect that plugins have. But if you use some of the open source plugins, then you might find that something that's supported in one plugin might not be supported in the other, just because nobody got around to implementing it yet. And then you might find another one that literally has support for everything, and you just set a configuration flag and you're good. Yeah, on the other side, right, clients Pinot, I already suggested, well, if you don't want authentication, of course, you can disable it. You can just secure it on a network level. You can go even a step further and not just use these kind of tokens to authenticate. You can also leverage the TLS client certificate, pretty much two-way TLS, but I'll dive into this later anyways. And we can also show you a little bit of an example of what pretty much the authorization piece looks like. Meaning, if I have basic auth, it's not just, okay, I have a username and a password. I can actually provide fine-grained permissions as well. And of course, the same applies if you use OIDC or OAuth 2. So as a more hands-on example, I figured, okay, I'll just slap this big configuration blob on the screen here. But I think it kind of gets the idea across. Let's just break down this entire screen into pretty much two parts. The one would be the definition part of how I would define, say, users in a simple basic auth scenario and give them some permissions. So on top, right, this is from the controller properties. It's essentially just a standard factory class, right? I mean, there's multiple that are available. We'll just look at basic auth here. We essentially define a set of principals, right? Say the admin and the user. We can assign them passwords. These passwords also can be injected from environmental variables. So if you're running Pinot in containers, that's actually a very straightforward and easy way to get passwords in there without, explicitly typing them out. And then there are 2 or actually 3 different ways how you can narrow down permissions of users in Pinot already. And one of these ways is to just tie permissions to a specific set of tables. It's like here on the 4th line, let's see, of the principals, you see principals.users.tables equals, my user table, baseball stats and stuff. This is really one of the straightforward ways how you can create users that are only allowed to interact with a certain subset of tables. And equally, you can give them permissions. For example, here, user is tied to only read permissions, right? Whereas admin essentially implicitly just gets all of the permissions. In theory, there's also a third way how you can narrow this down. You can actually set access controls based on endpoints that are being hit. So if you specify a service account and you want to be really, really sure that it only hits certain APIs, you can actually also list them in a list of endpoints. I just didn't provide it here because there's not enough space. And speaking of providing things, right? So on the other hand, I said every component in Pinot, as well as every client that talks to Pinot, will need to authenticate itself. And so at least if you were to specify these tokens inside of the cluster here, for example, for the server, in order to talk to some controller APIs, then you can provide these different tokens in there directly in the configuration as well. Usually, most of the auth.token properties simply take a string, and then whether you use basic auth or use JWT or other kinds of tokens, you can simply list them in here and write them up. I also dropped in the link to some of the docs here if you want to dig deeper into the authentication and authorization piece. But I think this is already quite a deep dive in some configuration details. So maybe let's go back up a layer and talk about how you actually use this. So assuming that you have a cluster configured with these properties that I showed you here, then how would you talk to it as a client? There are really multiple ways. Right? You can already see this. Whether you go, say, through the UI of Pinot, right? If it's configured with authentication, you'll get a small pop-up window that already asks for a username and password, so it's kind of baked into the JavaScript already. But even if you just go through a console, there are already a myriad of different ways of how these credentials can be provided. Right? One is the classic, username and password arguments on the console. You could provide auth tokens directly, right? So if you maybe don't want to use basic auth, but you want to use, say, an OAuth 2 implementation of access control, you can also just provide entire tokens here. And if you write job specs, you can also get these auth tokens both into the job spec or provided on the console. So different ways of getting it there, depending on how you feel comfortable about injecting these credentials. And if none of this works for you, and you just want to hit a REST API, then of course you can do just exactly what you would expect. You hit the REST API, you provide an authorization header, and then you take it from there. If it doesn't work, well, you'll get an unauthorized code back. Otherwise, the request will just be accepted as if, well, there is no authentication in the way. And well, it's fun to configure a system and then play with it. Instead, we figured, well, there might be a much easier way to do this by simply providing a quick start package that is already authentication enabled. So if you just want to play around, maybe write some scripts and just use authentication Pinot and get comfortable with it, this auth quick start tool is probably the easiest way to get there. It has pretty much all the configuration that you just saw baked in, and then you just get 2 users, one that is admin and very secret, and then that is user and secret, and you can get up and running quickly within 1 minute. Okay, so I think that part wraps up most of what I have for authorization and authentication. And I think we can move on and just talk about the next section that deals with encryption. Specifically, I figured I'll break this down into both an encryption in transit and an encryption at rest thing. Now, I already suggested that TLS and SSL is an important concept in Pinot. And in fact, it's actually so important that we implemented it end-to-end. This is, of course, one thing that was really driven by fintech requirements. We said, regardless which environment we're in, we don't want a dedicated VPC. We don't want to just terminate SSL connections at a load balancer. We want to be able to operate in essentially any environment, even if it's a shared network. And we want to guarantee that any data that is in transit in Pinot, both from clients to Pinot, as well as from Pinot servers among each other, is fully protected with TLS and SSL. So that really enables us to protect any kind of information that flows around pretty much without regarding too much of which environment we're operating in. And I already suggested, right, so there's both one-way flavors of TLS as well as client certs is supported. And that can be configured on a pretty fine-grained level, meaning you can, for example, protect everything inside of the cluster with two-way TLS and then enable one-way TLS for users from the outside. And just in case you still want to provide, say, unsecured connections, you can actually do this. And we implemented a dual ingress feature. This was actually earlier this year, where you can really go and have a cluster expose both protected and unprotected endpoints. And you can even transition those from one to the other over time so that you could start with a Pinot cluster that is completely unprotected. And assuming you have some redundancy, you can actually perform a zero downtime upgrade of an unprotected cluster to a fully two-way TLS protected cluster. It takes a couple of steps, but this was actually a really awesome feature just to get people started quickly, but then allow them to transition from a dev environment to essentially a production-ready, fully encrypted environment just without downtime. This was an interesting exercise, but it was also very rewarding to actually see the adoption of this. The other side, right, I suggested I'll be talking a bit about encryption at rest as well. I think the encryption at rest thing is probably the most boring part here, in the sense that Pinot simply relies on volume level encryption, meaning, of course, if you're in the cloud, right, and you use any kind of deep stores, you can leverage directly the cloud native encryption, meaning just whatever key management you need, you just plug it in and your data at rest is encrypted. If you're storing your data on physical volumes at some point, you probably want to use DMcrypt just to make sure that whatever is outsourced there, or maybe even just staged temporarily, also stays encrypted. One thing that has been a bit of an ongoing debate, and so here we would actually like to also get a little bit of your input, is whether we want to add maybe an additional layer of encryption actually directly in the system, specifically on the data segment level or even the row level, to essentially enable, let's say, safe multi-tenancy, where if you had multiple users actually share the same table, we could still contemplate, say, encrypting rows from different users with different keys, just to guarantee that access is only possible depending on well, the user and the credentials provided. But essentially, every time when we've looked at use cases that require this, well, this was usually a nice to have instead of a must have. So again, if this is something that you care about, we would love to hear about it. Maybe one good way to look into this and chat with us is a Slack channel. But anyways, I'll bring this up later. So let's just move on at this point. Actually, also speaking of encryption, I figured, well, similar to the way we defined authorization and authentication, I'll give you a quick example of what the configuration for SSL looks like. One thing is, right, I mean, you can already see this, there's essentially like three, let's say, important parts to this. The one is on top, just defining and pointing your JVM to pretty much a key store you can just set the default key store. Technically, Pinot has a way to also define custom key stores and trust stores. But usually just going the default route in the JVM is the way to go. The second part is, of course, again, the protection and the exposition of REST API connections. You can already see this here, right? This would be a configuration for dual ingress, where we support both HTTP and HTTPS connections, and we just expose them on different ports. Here, this is the config from the controller, right? So similar compared to this, you can also do the same thing for a broker or even for the server internally. And then the last piece is probably more relevant to the actual, the high traffic part of Pinot, which is the Pinot server, right? Like the binary protocol that serves data between broker and server. Even here, we use Netty, but you also have a choice between essentially just a plain unencrypted Netty or just the native Netty implementation of SSL tunnels. Same concept here. Dual ingress is possible if needed. And without diving too much into depth here, there's a complete reference and documentation of how you can configure TLS, even with different use cases, right? Going from no TLS to some TLS to full cluster TLS in the link that I've provided below. It's pretty extensive. And again, if you have any questions, also just stop by the Slack channel and we will help you out. Okay, instead of having actual examples here of how commands work, I mean, TLS and SSL is pretty standard, right? But even if you go and you look at the cluster, right, and then maybe you even have load balancers and you have your broker and your controller pane, and then on the lower level, you have the servers, the minions. I figured this is a good way to kind of look at what part of the system is protected how, both in terms of encryption, and then I also figured I'd bring back the authentication piece. Encryption, again, I said, this is like the most straightforward piece. You can protect everything everywhere. So Pinot is end-to-end SSL protected, meaning if you want and if you enable it, you can do this from the lowest level of the server stack to the broker and the controller. You can also, of course, go to the load balancer. So if for whatever reason you want to terminate your SSL connection at the load balancer, you can do this as well, but there's no need. I think the bottom line here is that Pinot is really a toolbox and it can be configured to suit your needs. TLS and SSL end-to-end is probably one of the coolest recent features that was built into all of this and really adopted over the past months. I also mentioned authentication, right? You can authenticate on the load balancer level if you want. Ultimately, well, there's tokens everywhere, right? So whether you hit brokers or controllers, users can be expected to provide tokens. If you just want to keep it, say, simple, you can also just use the SSL client certificate here, usually on the server and minion level directly. Typically, just client certs are enough to make sure that all the communication inside of the cluster is authenticated. Okay, and I think that wraps up the encryption section. And we can continue on in our journey and go to more of a data management or data retention piece. All right, yeah, so retention, replication, and deletion. You can tell this is a little bit of a collection of some different topics. What I'll talk about is here's a couple of interesting use cases mostly, and how they are addressed in Pinot. Of course, things such as the GDPR, right, to be forgotten, and other things, just to give you an idea of how to deal with some of the other challenges that come up when you bring up data protection. So let's take a step back again and maybe think back about that architecture diagram of Pinot. And as suggested, there's these real-time flows and there are these offline deep stores. And actually combining those is more or less of like thinking of Pinot as a Lambda architecture in a box, right? You have real-time data coming in, you have some historical batch data, and of course, over time, some of the real-time data becomes this batch data. And of course, in order to function properly, Pinot has to do some potential deduplication of data on the fly. But having this deduplication on the fly also enables a couple of interesting ways of dealing with problems that come up when it comes to especially compliance in this whole data management space. One is, of course, that, well, since these batch segments are in the deep store, they can be replaced. Meaning, if you have online data coming in, yes, Pinot will process it. Eventually, they will be collected into these data segments and will be stored in the deep store. But if you happen to find that some of the data in these batch segments has to be deleted, you can actually do this with some kind of a housekeeping job. Meaning, you could take one of these offline segments that was being generated, you can essentially open them back up, process them to remove or obfuscate some data, and then write them back. And if you do this, then of course the offline service will eventually pick this back up, and the data will disappear or be obfuscated in your cluster, and you can easily stay in compliance that way. Another thing is that when you talk about this kind of offline and online data, it's already good enough, right, using deep stores usually to have very long retention periods, but you don't want to really manage this retention yourself, right? Meaning that it would be good if you could just define those retention periods as policies. And this is actually also what has been put into Pinot, where you have pretty fine-grained control over saying, hey, this is how long I want to retain, say, some of the real-time data as it's presented. This is how long I want to retain certain offline segments. And then Pinot can take care of making sure that the data that is available in the system is indeed time limited, right? For example, for the last, say, 3 months or 2 years or what have. Of course, it can be indefinite too, if this is just the kind of data that you're working with. Another thing that comes up oftentimes is data masking, right? Where you have data coming in, potentially sensitive data from, say, a real-time Kafka stream. And when you deal with this kind of data, yes, you could do some manual processing and just do the masking somewhere inside of Kafka. But also this feature kind of eventually made it into the ingestion configuration of Pinot, where now there's some simple ways of how you can process and mask data directly at ingestion time in Pinot and move on with this. I also have an example of this later. I think, if there's anything really to take away from the slide and saying, there's already quite a bit of work that has been put into compliance related things. And there's also a lot of fine-grained control just on a table level, right? Where you say, okay, well, depending on which data, if it's very important, I can have higher replication for one table than another. Of course, I have ACLs, right? You already saw this in the authorization and authentication piece. So many, many things that can just be set and configured on a per table level, so that you don't need to set like cluster-wide flags, but instead you can really have multiple types of data in the same cluster and protect it in different ways, and also manage the data in different ways, just on a per table level usually. Let me just walk you through some of these samples, because I think they're actually quite interesting issues that are being addressed. One thing here is, if you look back, right, and you remember this diagram, essentially data coming in from Kafka, right, and then going into Pinot, and then we're trying to generate insights. I already suggested that I have an example of data masking, so I'm also going to walk you through this here, saying that maybe I have some PII data, Alex and his fake social security number, although it would be nice if this actually was my social security number. I can take this data, and I already suggested, well, it should be possible to mask or at least transform this data. Right? So I could go ahead and, for example, obfuscate the first couple of digits, or simply go the full obfuscation way. And then, for example, apply one of these groovy functions and just say, hey, just hash the SSN with SHA-256, and then write this data into Pinot. And of course, if you implement this in a real world scenario, you probably want to salt it and do a couple of additional things. But I think this is just a very straightforward example to show how data masking and obfuscation can be achieved just simply by configuration in Pinot without adding some additional Kafka pipelines. And so, of course, you have the name and the SSN structure still maintained, but of course, the data in the SSN is obfuscated. And so if I do this, I can still actually do quite a few queries, and I can still work with aggregation, but I cannot extract the SSN directly. Right? So if I have this very truncated SQL statement, right, where I say, hey, I want to select the name where the SSN equals some value, I can still use it to essentially extract information if I know the obfuscated data. But the other way around, I cannot accidentally extract the SSN just by providing a name. So this is, I mean, a very simple example, right, of how data obfuscation could work in Pinot. You can get, of course, arbitrarily complex, as this already suggests, right? I mean, a Groovy function is something that can go very far. You can make different method calls. I mean, you could technically even reach out to other services and other things, just at ingestion time, to really shape and mold the data to suit your compliance needs. A second example that I also kind of brought up, as I said, GDPR has some history with Pinot. And one of the interesting challenges that came up here was, of course, the right to be forgotten. Right? And right to be forgotten just means, well, yes, you have data retention policies in your company, and you'd say like, hey, you just retain certain amounts of data for 3 years. But if an end user comes around and sends you a letter and demands that you remove pretty much any trace of their data beforehand, then you have to do this, or you at least have to obfuscate any kind of records about that user in all of your data stores. And of course, that also affects your OLAP system, or Pinot in that case. The high-level solution, I already suggested this, right? You have real-time ingestion, while eventually this real-time data is packaged into these batch or offline segments. And then Pinot can handle this online deduplication of real-time information and these offline segments. And the offline segments can essentially be opened up or be regenerated even from source data by some kind of housekeeping job. And you can then just replace these segments in the deep store, and then eventually the service will pick it up, and therefore whatever data that has to be deleted will actually be cleaned up and become unavailable just on the fly. And this process can be repeated just in arbitrary time intervals. Right? So you're not really tied to a specific point where you can either delete or not. This is just something that allows iteration and staying compliant overall. I also thought I'll draw a little chart because it's much easier to understand when you look at this. Right? So let's say we have this real-time server group that ingests data from Kafka. Eventually, Minion picks it up and packages it for the offline group. And this data eventually goes into a cloud deep store. Actually, in the meantime, you can even skip the minimum step, like the real-time service can write to the deep store directly. But regardless, you take this, right? Whatever data segments you have, right? They end up in this segment deep store. And eventually, you can just have some kind of a housekeeping job. I mean, I put Spark here, but you can really do whatever you want. And either reopen these segments and just obfuscate or remove the data that should be removed. You could also just regenerate the entire segment if you had, say, a store of your streaming Kafka data at some point as well. Anyways, I think there's many ways to achieve this. The bottom line is that, well, there's dynamic segment reload, and you can just modify the data, and eventually Pinot will pick it up as well. Okay. That was actually already pretty extensive. I mean, there's many other examples I could bring up here, but I think if there's one thing I really want to take away from this is that Apache Pinot has a history already of data security and compliance. And I mean, I put a bunch of different examples and use cases on the right side. Of course, it's known as being the data lake of Pinot. Well, the data lake of LinkedIn. It's being deployed widely by Uber. There's a couple of larger fintechs that also use this, both for visualization use cases. There's, again, A/B testing platforms built on top of this. And there was quite a bit of legwork that was put in by dozens of developers to actually work and GDPR compliant and other environments that have data security and compliance needs. And I think with this, I can already go towards wrapping it up. One thing we did about Pinot, right, maybe to loosen it up a little bit again, is a community survey somewhat recently, right? We know of at least 50 companies that deployed in production in the meantime. It was really awesome. Also, we just hit 1,500 users on Slack. That is good. I'll also happily invite you to join us because it's usually a great place to just talk to people that have lots of experience already building on top of Pinot. We try to get some performance stats, right? There's deployments with over 1 million events ingested per second in a compliant way. That is pretty impressive. There is, of course, high query lots that are being supported. Anyways, it was very cool to actually see this kind of adoption after sometimes, quite a bit of work. But yeah, now this is really picking up. And again, it's very rewarding to see this. And I'm happy about that. So with this, I'll just leave you with that. We are now 1,500 on Slack. That is pretty awesome. It's very active. I invite you to just join us in the Slack community. Maybe just follow us on Twitter as well. But I guess the best way to reach us after you've maybe Googled a couple of things of Pinot and you're interested is just to say hi in the Slack community. And with this, let me wrap it up. If there are any questions, I think we'll just dive into a Q&A right now. And otherwise, that's it from my side.
All right. Thanks, Alex. That was awesome. Appreciate the info on data security in Apache Pinot. And I do have a couple questions that were asked during the stream. So let's go ahead and get those. One of them is it possible to integrate Vault for key store management into Pinot, similar to how you can do it with Kafka?
Yeah. So we already have some deployments where we have Vault and Pinot integrated. The one thing that we do not directly have right now is a plugin in Pinot that says it can pull, say property values with Vault. So this is definitely something that is already happening, but there is no complete solution or plugin in the configuration management, say, for example, of Pinot yet.
Right.
But it's coming.
Okay, so there would be a manual configuration where you connect it up.
Yeah, so essentially, right now, you could already use Vault, but you would probably have to inject certain properties as environmental variables, and it's kind of clunky. So what is happening, right, it's not there yet, is that there's a plugin so that it just directly talks to Vault.
Right, cool. Another question that we had was, can you extract data from Pinot? They said there's a lot of information out there on ingesting data from different sources, but how do you actually get data out of Pinot? And obviously you can query it and build dashboards and stuff like that, but they were specifically talking about like CSV extraction or something like that. But
yep. So right now, what Pinot really essentially the one way how Pinot responds to you is with SQL, right? So any query that you write goes and hits a SQL-like interface eventually, and then the data that you get back just depends on pretty much which connector you use. Right now, the two most common ones is, of course, pretty much a REST or a JSON like output, right, where you just you send a SQL query and then you get a JSON construct back. Or of course, there's a JDBC connector as well. Right now there's no specific CSV thing, but again, we've heard it a couple of times, so this is also something that is in the oven, so to say.
Yeah, it would be pretty straightforward to take that SQL response and extract it to CSV, but it would be nice if there were just a export my query.
Yeah, no, in reality, right, I mean, you could just say like, hey, I expect a certain encoding in the output, right, and Pinot should just pick it up like classic, like REST way. Anyways, yeah.
Cool. I had a question, and that was about RBAC. Like, is RBAC built into Pinot, and then what's like the granularity of the permissions that you can set?
Yep. So I showed an example of like basic auth, right? The way that it's implemented in open source. Technically, this basic auth thing has just pretty much you create users, right? The user is the role there. The permissions are already pretty fine-grained, right? So you can go what type of permission, right? Is read, write, update, delete, the classic like CRUD, let's say. You can tie it to specific tables or like these kind of table namespaces. And then you can even go to the endpoint level, right? Where you say, hey, I don't know, I have a service account and I only want it to hit the, create table endpoint. You can even tie it down to that point. if you want to get a step further, right, where you say, okay, maybe you're even integrating with OAuth2 or like OIDC. But this is, this is where it kind of starts going into the not open source space. Of course, then StarTree also has a solution for authentication. There's like full RBAC, right? We have like roles, and you have users, and you tie them to claims in the JWT tokens, and then you can even go to column level in terms of granularity. But yeah, this is yeah. So if you're talking about open source, essentially it stops with here's a user, and then even tie it to a table or an endpoint or something like that.
Right. Okay. Cool. Another question just came in, and that is, can you say something about Pinot running in Kubernetes, especially security related to Kubernetes? As I would imagine, even in the Vault scenario, you could connect Vault to Kubernetes and have it inject secrets. So
exactly.
What else can you do?
Yeah. If you're, by the way, because you just mentioned that, yes. So if you tie a Vault into Kubernetes and then have it inject secrets, that's actually usually a standard way how people handle this. It's also Pinot. Pinot comes from a world where it was deployed on bare metal, but right now, pretty much any larger Pinot deployment that you see runs on Kubernetes, right?
Yeah.
Meaning that the integration with Kubernetes is it's pretty decent at this point. That said, in terms of security features, well, yes, you inject, say, secrets, right? The way that you know it with Kubernetes, and you just pick it up in any kind of config files. When you deploy Pinot in Kubernetes, let's say the encryption angle must handled by whoever hosts that JVM or hosts the deep store, right? Which is, I don't know, like GCS. So this is not so much of a concern in Pinot. On maybe the data in transit angle, of course, right, you deploy Pinot with a load balancer. So you would configure a load balancer, for example, that just allows either TLS or SSL connections. I've also seen people just deploy it in a way where they terminate their SSL at the load balancer and then just have their cluster in a separate VPC. So I've seen many ways how people have done that in terms of, it's a toolbox, essentially.
All right, we got another question that just came in. So a lot of questions. This one is, how can you ensure high availability of the Pinot database? Can you talk about replication? And stuff like that?
Yeah, I kind of skimmed over that in the talk. Right? Essentially, all of Pinot is really at the point where you can have no single point of failure. Right? So essentially, everything in the system is highly available. Of course, right, there's the controllers, right, which kind of like manage the cluster state. There are multiple of those. Right now, they rely on Zookeeper. Let's see if this is eventually going to go away. But yeah, like both of them are, of course, like replicated. Then the actual data path, you have brokers, right, and you have servers. Essentially, the brokers mostly handle combination of data that comes from different servers. The servers are then really the low-level pieces that store, these like data segments. Right? And so any piece in the cluster can be replicated, and the replication can even be configured, let's say, on a logical level. You say, hey, for example, here's a table, and I really want to make sure that it's always available. So replicate it, this table on 3 or even 5 servers or something like that. And so if this ties into a cloud deep store, right, where like S3, you can really have scenarios where half of your cluster dies. It's not going to happen, but it could happen, and it's still gonna keep running. Right? So this high availability was like one of the most important reasons actually why Pinot was built in the first place. And yeah, so this works very, very well in the meantime.
Awesome. All right, that's all the questions that we have in chat, unless there's any more that come through here in a second. But appreciate you coming on the stream and doing the meetup and telling us about data security. Definitely excited to see all the things that are coming in the future as well.
Yeah, Matt, well, thanks very much for hosting. This is also good to have you on board. And this is good. I very much enjoyed this. I hope we can do another one of those.
For sure. We'll be doing a lot, I'm sure. So All right. Well, thanks everybody for coming. This will be recorded and available on our YouTube channel, so definitely check it out there. If you're not in our Slack already, please join our Slack. You can just search for the Apache Pinot Slack and you'll find that link. I don't have it handy. Corinne didn't quite set me up with that, but I'll get better at that as we go. And then also follow us on Twitter. You can follow me as well. I'm Matt_Landers. I'll be posting lots of stuff about Pinot, and then we have Apache Pinot and StarTree data on there as well. So follow us. We'll post lots of content and answer any questions that you have. So thank you for joining this stream, and go out there, build something awesome with Pinot, and happy coding.
Join us on Slack.
See ya.
See you guys.